Hi, everybody. We're live today. This is an unscheduled stream, so I'm not expecting anyone to jump in, but if you do, say hi. Also got the radio set up on on Ontario wide. Talk group 3023. If you have a DMR radio, punch in, say hello. VA3FUC, that's all I have to call me out. And I'll hear it on the radio, and I will be more than happy enough to join you. See, right here. So, why am I restudying the test? Well, I didn't fail it. So here's the situation. I'm rewriting my test to get my HF. So the first time I wrote my test, I got 74. Not enough to get HF. I was short 6 questions from getting 80. So I'm going back through the exam generator and just reminding myself all the questions, and then I will rewrite my test, and hopefully I can get 80 or better. Hey, Andy Cowley, thank you for coming in. So let's go into what a Canadian exam looks like, so you guys have an idea what I would do. So there's the Canadian amateur page. This is on the Ontario government's website, and I can do the basic study questions. I can do a basic practice exam, print the exam, print a basic official exam. This requires to log in. So this is for the examiners. I can print all basic questions. I have done this. I have a full sheet. It's about 29 pages, double-sided, of course, printed. Saves on the cost of ink. And I have them all printed and all put into, got zip tied just because I was too lazy to go buy a binder. And there was just too many to fit in like a dual tank type idea. So I printed them all out, used those plastic inserts, slid them all in, and that's the way I got them organized on my, in the thing. So I can always go in back and look through it over and over again and restudy from there. So what we're going to do the basic practice exam. Now, the basic study questions, it just gives me 100 questions and it gives me an answer key. So that you do offline, you just write on paper. But to save money and save paper, because who wants to waste millions of trees just to write 10 or 15 exams just so I can get better at it, we're just going to do the practice exam here. This I have approximately about 2 hours to do. So let's get into this. So what is a Qsl card? A postcard remaining when your certificate expires. Is it notice of valuation from the Information Science Examiner of Canada? A letter or postcard from amateur pen pal? Or D, a written proof of communication between two amateurs? Now, the thing is, it looks like a postcard. So but it also is written proof and proves that you've gotten that contact. There you go. It is D. So we're going to go into each one of these and we're going to see how it goes and go from there. So to Andy, thank you so much. I'm going to put that in. So he is 2 Echo 0 REE. So that would be 2 Echo 0 Romeo Echo Echo. So thanks for coming in, man. I really do appreciate it. And if I remember, that's you're from the UK, right? With that kind of call sign? Oh. Okay. Didn't hear anything, but I saw something flash up on my screen there. Okay, let's go into the next question then. What's the meaning of your signal report is 3-3? Your signal is unreadable, very weak in strength. Your signal is readable with consistent difficulty and a weak strength. Your station is located in latitude 33 degrees. Your contact serial number is 33. Well, we know that one's totally wrong. I've never heard of a serial number 33. And I never heard of anybody giving their longitude and latitude. So we can kind of strike these two out. Signals unreachable and very weak in strength. Well, for me to give you a signal report, I have to be able to reach. You have to be reachable. So I'm going to say reachable, considering difficulty, weak in strength. Because it just makes sense. How are you going to give someone a report if you're not close enough? And B is the right question. Next one. A lot of these are going to be. Okay, turn that down. Characters in impedance of a transmission line is determined by. Oh, this is going to be fun. Frequency at which the line is operated, length of the line, load placed on the line, physical dimensions, and relative position of the conductors. So we're looking for impedance and what causes it. Good question. I'm not even 100% sure on this one. Either it's physical dimensions or length of line. And I have a feeling I'm going to get this wrong, but I'm going to go with what feels right. And I'm going to say length of line. Now, I could be wrong. There's always a possibility I can get this wrong. Like I said, restudying for my exam, seeing where I'm weak, seeing where I'm good at. It's actually physical dimension, like I thought. I was unsure if it was B or it would be D. And D is the correct answer, so we got one wrong. Next. Which of the following term does not apply to packet radio? AX25, ANSI, Automatic Packet Reporting System, APRS, or BALDOT? Interesting. I believe AX25 is a actual digital mode. ANSI is digital. We know the automatic packing system, APRS, is a digital mode. I'm going to have to go with BALDOT, not being the digital mode. And we got it right. Got it right there. Number 5 in the 100 questions I got to answer. What is a good way to get maximum performance from a Yagi antenna? Optimize the length and the spacing of the elements. Use RJ56 transmission line. Avoid using tower higher than 9 meters, 3 feet above the ground. Using a rectangular bridge to measure the antenna performance from each direction around the antenna. A lot of these sound dumb, especially use the transmission line. Okay, maybe, but we know that the antenna is consistent of length of elements, and how the elements are spaced gives you the right amount of signal. Unless someone's asking for a test, call sign back. Okay, let's see. VE3 BWP. This is VA3 FUC. I am hearing you loud and clear.
Hey, thanks, Ron. Yeah, I was just helping Bert here remotely, with these passwords now, the Brandmeister password. So I was just checking that. So he was on the American server and it locked him out. So anyways, just testing that. So thanks. Sorry about the chatter.
Oh, no problem. I just want to let you know that I'm hearing you loud and clear in case you were having a radio issue and you weren't getting a reply back to see if it was working. So I do apologize for interrupting you guys. I'm just sitting here doing my test and working on some stuff here. So I'll let you get back to it. VA3 FUC.
Oh, no problem. I appreciate it. Yeah. No, just, yeah, I don't know if you read up, but the hotspots are supposed to have passwords now, at least in the American server. So I was just implementing it here because I had Bert's BMY set. I guess it somehow it was on 30. It was on an American server and he got locked out. So, anyways, I'm just testing just rebooting his hotspot now. So I'm doing it remotely. He's in Wasaga. I'm here. So hopefully you'll hear us both chatting in a minute. Okay, thanks again. Take care, Ron.
Yeah, glad I was able to assist if that VA3 FUC. I'll give him my 73s and I'll be clear. So I'm still on the service if anybody wants to reach out to me, but he said yes, he is in the UK, so that was great. Let's get into this. Okay, so for the antenna, I'm going to say A. And A is correct. Next. In a CW transmitter, the blank is in between the driver buffer and stage. Sorry, driver buffer, stage, and antenna. These are the questions I hate the most. Because you have to remember 55 drawings. It feels like that. You got to know what goes into where and how and when and how, why. So this can be very confusing at times. So in a CW transmitter, the blank is in between the driver buffer stage and the antenna. I don't think it's a telegraph key because I think telegraph key goes after the is in the transmitter. That's true. But I think it's past the power amplifier. I think it plugs into the power amplifier and the amplifier then power, yeah. Power supply? Maybe, but I doubt it. Master oscillator? It could be. Or is it telegraph key? Jesus. Okay. Gee, I don't know. I'm going to try master oscillator. I have a feeling it's going to be wrong, but it's the only one that seems to make sense to me right now. Let's see what happens. It's actually the power amplifier. Okay. So in a transmitter, the CW blank is in between the driver buffer stage and the antenna. So let's pull out the book. Okay. CW transmitter. Okay, we're going to go back into full screen so we can have a look at this. That's it right there. So, master oscillator, then driver buffer, then power amplifier, then at the end is the antenna. In the middle of your driver buffer and power amplifier is your telegraph key. So that's in the center. So I kind of knew it wasn't that, but I wasn't too sure where the power amplifier is. So the power amplifier is in between the driver buffer and the antenna. So the power amplifier is even before goes into the key. So that makes a little bit more sense now. Okay, let's go into this again. Next question. A lamp has a resistance of 30 ohms and a 6-volt battery is connected to it. The current flow will be. So at 30 ohms, that would reduce it to 2 ampemeters, I think, if I remember correctly. Because resistance is causing it not to get the full power of the voltage. So then we have to convert the voltage to ampemeters. This is where Ohm's law and power law comes into place. I believe it is 2 amplimeters, if I'm remembering this correctly, my math. No, 0.2. Carry, carry the one. Ah, damn it. Forgot to carry. Okay. If your mobile transceiver works in your car but not in your home, what should you check first? The power supply, the SWR meter, the speaker, the microphone. Well, since the transceiver works in your car but not at home, I would definitely first. Oh yeah, I should put this on so you guys can see it. Add to stream. There we go. Sorry guys. So if a transceiver wasn't working, it was working in my car, the first thing I would think is maybe look at the power supply. That would be my first thing to look at. Am I getting enough power? Is it powering it up the radio? And the power supply is the right question. Question 9. A radio apparatus may be installed and placed in operation, repaired, or maintained by a holder of an amateur radio license with the advanced qualifications on behalf of another person. This is something that I understand why the question is way worded, but should be more clarified. Because I know there's people out there that listen to shortwave that have very similar equipment to what amateur radio operators will have to listen. So, but by law, you cannot do this. So here's the answers to the questions that I can answer. At the other person is a holder of an amateur radio operator certification and the amateur radio service. Pending the grantee of the radio authorization, an apprentice covers the amateur radio and commercial band frequency. If the transmitter or station for which a radio authorization is to be applied for and type of approval of a Qsl controlled, or D, pending grant of an amateur radio operation certificate if the apprentice covers the amateur radio frequency bands only. None of those are correct. It really is A, though. If the owner of, because they only want you working on other amateur radio equipment if you're authorized as an amateur radio operator. It is very key wording there that you got to watch out for that can throw you for a loop and a half. So anyways, in order to install any radio apparatus to be used and specifically for receiving or automatic transmission, radiophone communication within the same frequency band, the radio amateur must hold the amateur radio operator certificate, a minimum of which one? Basic with honors, basic and advanced qualifications, basics and Morse code probably, or basic qualifications. In order to install any radio apparatus, to use specifically for receiving and automatically transmitting radiophone communication within the same frequency band, a radio band of a radio amateur must hold an amateur radio operating certificate with a minimum of any band. So that makes me think we're talking HF also. Now, I know a basic operator can operate a radio under someone else's call sign, but if he's running his own, and the minimum he's going to need would be basics with honors if this is HF. But he's already must hold an amateur operator with a minimum of, I want to say basics with honor qualification, but if it's 2 meter, then all he needs is basic qualifications. Oh, decision, because both of these are right. I'm going to say basic, But I have a feeling it's going to be advanced. Yep, basic and advanced. So I should have gone with A. I mean B. Oh, no, basic and advanced qualifications. Well, that makes absolutely no sense, though. Because if it's any radio frequency, why would they need the advanced for? Something to keep in mind then. That's kind of a little tricky because even a basic operator could receive HF but could not be able to retransmit on HF, but could retransmit on 2 meter. Next question. The maximum bandwidth of an amateur radio transmitter is allowed in bands 28 to 29 megahertz is which band? Six kilohertz, 20 kilohertz, 15 kilohertz, or 30 kilohertz? Probably maybe 20. No, that seems a little bit. 6 kilohertz seems too small, but that would be sideband. 30 kilohertz is AM. 20 kilohertz would be FM. 15 kilohertz seems a little bit odd. I'm leaning towards 6, but 6 is also used in digital. Okay, so that's 28 to 29. I don't think it's 20 kilohertz. 7, 8, 9. Yeah, it's 20 kilohertz. I believe I'm doing this right. No, 30, my bad. No, it was 20. My math, bad math. No, it is D. I would have been right if I picked D. I think 20, and then I double guess myself. Always go with your first answer. Never double guess yourself. This is something I've done, and yeah, my bad. So, Evero Ramos, thanks for coming in. Yeah, it is 20. The answer is 20. I'm goofed on that one. I was thinking, you've been training. Congratulations. This is the book I use that was recommended by my club to get. This is the amateur. Let me go zoom in on myself so you guys can see what I'm looking at. Come on, where's my mouse? There we go. Okay. So layout. So this is the book I've been studying from. This says is from 2017 and 2018. 2019, same information. This will help you immensely for studying. This has key codes in the back of it. Each followed with a question, follows with all the questions for that area in the bank. Very helpful book, because if you are not understanding something, then you can go back in this book, verify what questions those are, and then go back and attack them. Why not this year? You can even try this year to get it too. It doesn't hurt. Yeah, but as long as you continue with this website like I'm doing right now, just going over it again and seeing how I'm doing. So far, I've gotten, out of the 11 question answers, I've gotten 6 right. So that means I've gotten 4 wrong. Not good, but then again, like I said, I'm repracticing, I'm restudying, I'm finding out where my weak points are. We are doing it over here in Kitchener, Waterloo, and we're doing it over Zoom. Hit me up via Canadian Maker Project at gmail.com. I will talk to my examiners up here, to my class up here. And if we can get you into a class, we can get you set up that you can learn this, get trained. And then you'll be able to write your exam anywhere in Ontario, in Canada. You can even book some time at one of the exam offices in your area and do the test that way. But I would also check with your club, see if your club is willing to, see if there's an examiner with that club in Ottawa. Ask the examiner, if I'm ready to write, would you be able to examine me and give me my license information? Sometimes they'll work out deals for you to do that. Okay, someone's transmitting. I have no idea who. Weird. Okay. Well, how about if I make this easier? There's my email address. You can send it there. You could also go into my About page, and I have all the information there, how to contact me. So I'll put it here for you, and you can contact me that way. Anyways, let's get into this. Total resistance of a resistor connected in series is equal to the highest resistance present, greater than the resistance of any one resistor, equal to lowest resistance present, less than the... Okay. Less than the resistance of any one resistor. I'm going to turn off the radio here so we can concentrate on this. This one is tricky. Without any values, you have to understand how resistors work. So there could be 1, 2, or 3 resistors. Yeah, equal to the highest resistance, which is present, makes most sense. Greater than any of the other resistance that any one resistor does not make sense at all. Equal to lowest resistance present. No, because your resistance is going to be high or low. It doesn't matter. Less resistance than resistance of any other resistor. That makes no sense. Yeah. Which is A, equal to the highest resistance at present. Submit. No, it's not. I'm going with what he gave me. So, anyways, B, greater than the resistance of any other resistor. What happens is, when you take one resistor and one resistor, whatever has the greatest resistance is going to be first in your series anyways. And that resistance is going to be greater than the next resistant. It's just mathematics, how mathematics and electricity work. So, yeah, I should put it back up. Here we go. Add to stream. There we go. Next. Keep forgetting to hit that button to turn it back on. Okay. If you're a net control station of a daily HF net, what should you do if the frequency which you normally meet is in use just before the net begins? Cancel the net for the day, reduce your output power, and start the net as usual. Call and ask the audience to relinquish the frequency for the scheduled net operation. If this is not agreeable, Conduct the net on a frequency 3 to 5 hertz away from the regular net frequency. Increase your power output so that the net participants will be able to hear you over the existing activity. Well, hell, yeah, we want to do D. Increase the power. No, there's something to be said about amateur radio. We're all polite in this world. You know, we ask, is the frequency in use? There are other people that will just run way over you just because they want to be... They want to be AH. We'll just say AH. And they believe that they own the frequency. No one owns the frequency. So let me be clear about this. No one owns a frequency. There's no such thing. Unless you're paying lots of money. There's no such thing as owning a frequency. So D is totally wrong. Cancel the net for a day? No, you can move. Net can be anywhere. Reduce your output power so the net starts as usual. That has nothing to do with power. Has nothing to do with this. C is the most obvious one to re-rebalance the frequency. But they are not agreeable. Conduct the net on a frequency 3 to 5 hertz away from the regular net frequency. So that way your net can hear you, but you're not causing any interference. Let's see is correct. Next. Why might a dummy antenna get warm when in use? Because it absorbs static electricity? Because it stores radio waves? Because it stores electrical current? Because it changes our RF energy into heat? Now there's two ways to look at this. One, we know we put power into an antenna, and we know that that energy is burned off as in heat. Okay? Because we're putting out our radio waves too, we got to keep in mind of SWR, signal wave length. No, single wave. SWR, signal wave. Impedance? No, resistance. So SWR is something else that you'll learn about antenna theory. So looking at this, static electricity is out of the question. Because it stores radio waves. Well, an antenna doesn't store, it allows antenna waves to go out. Because it stores electric current. Well, an antenna does not store electric current. There's no battery, there's nothing attached to it to allow it to store. So the only way it can be is because it changes RF energy into heat. And that's what it does. It turns the energy into heat and anticipates the heat. If the center of an impedance of a folded dipole is approximately 300 ohms, and you are using an RG8U 50 ohms coax line, this is key here, what is the ratio required to have the line and antenna match? Would you need a 6:1, a 2:1, a 4:1, or a 10:1? So we're doing 300 ohms. We're using RG8, which is 50 ohms. 50 into 3 is 3:1. If I remember correctly, I believe it's a 4:1 is what we're looking for here. No, 6:1. 50 goes into 300. 4? No, because 50 goes into 4. Oh, I'm doing my math wrong here. No, it's 6:1 is right. Yeah, my bad. Like I said, my math questions, I stink at. Next. If a voltmeter is marked in volts, used to measure 300, 500 millivolt potential, what reading will it show? 0.35 volts, 35 volts, 3.5 volts, or 350 volts? Milli. And we're counting that to volt. So that is 1,000,000 volts. Bringing it down to volts. Okay. My math is going to be really rough on this one. We know it's not 350 volts. That's wrong. 3.5 volts? Maybe. 35 volts? Maybe. 0.35 volts? Maybe. I'm trying to remember how many decimal places it is for the milliamps. And then you can calculate what it would be. I'm leaning towards 0.35 volts. And my math is right. Let's see. 3.5 volts. That was going to be my other option. See. Yeah, 3.5. Yeah. Like I said, mathematics. I suck at it. What should you answer a routine Morse code CQ call? Send your call sign 4 times. Send the other station call sign twice, followed by DE, followed by your call sign twice. Send your call sign, followed by your name, station location, and signal report. Send the other station call sign once, followed by DE, followed by your call sign 4 times. This one's easy. If I remember correctly, DE is CQ in Morse code. It's just the way it's pounded in your key. I believe you send the other station signal twice, so they hear you, and then you follow it with your call sign twice. If I remember correctly. My Morse code's a little rusty, but if I remember correctly, I believe it is that. I don't do Morse code. I'm not a fan of Morse code, but Morse code questions are part of the exams, so it's another thing you're going to have to brush up on. Yes, I still know my Morse code information. I had to copy Morse code when I first learned amateur radio the first time I tried to study for it. I was good at Morse code. I actually passed Morse code really well. Oh, here comes another fun one I love. In a frequency modulation transmitter, the microphone is connected to the what? The power amplifier, speech amplifier, oscillator, or modulator? Well, I know it's not an oscillator, so we can take that out. Power amplifier? Probably not this time around. Modulator and speech amplifier both have its own theories and knowledge. Both do work with a microphone, but I'm thinking speech amplifier. Because once you speak into it, it needs to transmit the power into, Yeah, this is a little bit interesting. And I will go and I'll pull up the diagram for this. So I'm going to hit submit. I think it's a speech amplifier. Yeah. So, sorry about that. Let me hit solo there. Let's get the speech amp. Let's pull out the book again. Which one was that? That is frequency modulation transmitter voice. Okay. Amplifiers, receiving fundamentals. One thing you're going to find with this Scott, you might want to talk with Evero Ramos. He's looking for a class to learn amateur radio. He's out in Ottawa. He is looking for a class they can do online and learn. Do you know if we have a class going on anytime soon? And hey, Jen, VA3XXD. She is also one of the cohorts of a club I'm part of. So, Ramos, I used to live in Deep River. Why would I not remember about Ottawa and everything else? I lived on the freaking Ottawa River for a little while. Yes, I spent a summer in Ottawa. Usually go up there during the summer. Since it's been getting more hotter than normal, I don't go there until probably the fall. I go up to the river. What's really interesting this year, I'm going to have some fun, is if they have it set up, I'm looking forward to maybe getting my license, and who knows? May I'll be able to do some band transmission, HF, and smack it across on the we'll smack some signals across the whatever you call it, the Aurora lights, and see what I can get. Anyways, yeah, so here's something for there's an HF station. Give you an idea. Sometimes you got to remember all these things. Yeah, let me see what's going on with questions here. Okay, I don't think we're ever going to do POTA on Parliament Hill, but I don't think Parliament Hill is part of POTA, my friend. Plus, I think we'd have all the Secret Service agents charging up the charging us on the hill and tackling us, thinking that we're trying to blow up the Parliament building or something like that. Okay, on to the next one. There we go. Practice exam number 19. What is a parallel conductor transmission line? A center wire inside an insulated material which is covered by a metal sleeve or shield. A metal pipe which is wider and slightly wider than the wavelength of the signal that it carries. Two wires twisted around each other in a spiral, or two wires side by side held apart by insulation material. I've actually got to see one a few days ago at a certain person's house. And I believe, if I remember correctly, it is two wires side by side held apart by insulation material, D. And D is correct. Yeah, you. Really, Scott? That's always good. Yeah. Well, you know why I remember what it looks like? I was over at a friend's place and I saw his antenna in his trees, and I remember what type of antenna that was. So probably if I didn't see it again, I wouldn't have figured out D. But then again, I'm pretty good when it comes to antennas. I can usually spot Yagis and dipoles and all that little fun stuff. But anyways, getting off topic, let's get into this. If you're planning to install and modify an antenna system, under what conditions may you not be required to contact land uses authorities to determine public consulting requirements? Oh, this stupid question. Okay, this can throw you for a loop and a half, this question. It has thrown me a couple of times when I've read it. And if you're planning to install or modify an antenna system, under what conditions may you not be required to contact land authority authorization to determine public consultation is required? When transmitting is only done at low power, when an inclusion certified defined by the Innovation, Science, and Economic Development of Canada applies, when a structure is part of an amateur radio antenna in a rural area. And usually you go with the longest answer. Sometimes that's the longest answer is because it has to be very specific. And I think it's when an inclusion certifies the defiance of the Innovation, Science, and Development of Canada applies, if I remember correctly. This one kind of threw me for a loop because there is another one that could be pulled into play. I don't think it has anything to do with the rural area. Yeah, this is a trick question. I agree. Yeah. Install or modify when the structure is part of an amateur radio antenna? Well, you're modifying it, yeah. Then it's a structure of a radio antenna. Part of it. These are questions I get hung up on, the ones that are very tricky. Okay, we know that when transmitting low power is not right. Okay, well, we know A is out of the question. Because it says install or modify, it makes me want to go over to B. And B just sounds right. But so does D. But if I remember correctly, usually it's the longest question is the answer, if I remember correctly. I'm going to say B. Yeah, these are the ones you run into that just go, what? There are some in here, I'll warn you. It is very tricky for the answers. Semiconductor is described as a general purpose audio NPN device. This would be a silicon diode, a bipolar transmitter, an auto detector, or a trioid. I believe it is a silicon diode. Nope, bipolar transceiver. That's bipolar. Yeah, I never did well in basic electronics. That's where I'm weak. So my electronic stuff is a little weak. Granted, I don't do a lot of electronics. I do a lot more in, um, like if I need to replace capacitors and that type of stuff. I've done that type of electrical work. I can read electrical appliance, but when it comes to knowing what in what, yeah, that's where I kind of goof up a little. But you give me a diagram and I can read it inside out and I can follow it. That's the funny thing. This is the most interesting question at all because I've never heard of any of these other ones. Okay. What is a proper distress call to use when operating in CW? Mayday, CQD, SOS, QRRR. QRRR, I don't think it's that. I've never heard that. I've heard of SOS as for Morse code. CQD? Nope. And Mayday would just take too long to transmit. It wouldn't be that much to transmit, but it'll be faster SOS to be 100% true. So, yeah, it's just one of the things you gotta. Some of this is like common sense knowledge. Some of it is not. More circuit stuff. Yay. In a series of an LCR circuit is tuned to the frequency source of the line current reach maximum, line current leads amplified voltage, impedance is maximum, or line current lags the appropriate voltage. Well, impedance is maximum. That doesn't sound like that would be it. Line current reaches maximum sounds to be correct. LCR, line current. That could be wrong. Line current leads the applicant voltage. Line current reaches maximum. A sounds to be correct, but I have a feeling it's not. But let's go find out, and if it's not, then I know where I got to study. Nope, it's correct. Yeah, all it takes is one to get you all tied up. Lithium-ion batteries should never be recharged, left disconnected, left overnight at room temperature, or short-circuited. Gee, what would be the answer to that one? Duh. You never short-circuit an lithium-ion battery unless you want to kill yourself. Short-circuit a lithium-ion battery will produce a gas that leaks out of the battery that can be very, very, very deadly to your lungs. Can leave you actually scarring your lungs by breathing in any of the fumes that a lithium-ion battery will produce. Yes, battery theory is another thing I'm okay on. Let's put it this way. I'm looking at building my own battery pack for amateur radio usage. Anyways, voltage regulation is the principle applied to the xenon dioide, light emitting dioide, junction dioide, vacuum diode. Okay, well, I don't think a vacuum diode would be using it. Xenos diode, I don't believe it's the right one. A light emitting diode usually will only turn on if it has the right amount of voltage. Overvolting it will blow it out. So I believe it's B if I remember correctly from this. No, it's the xenon diode. Ah, oh well. I didn't think I was thinking of light emitting because, well, I've seen them blow. It ain't pretty. Okay, so remember that question. Now remember, when I go back into this, once I'm done these whole exams, it gives me a list of everything I passed and everything I failed. But also will tell you what areas are you strong in, what areas are you not strong in. So you can review your book and remember these all this terminology too. That is true. Yeah. So what it said here, it blocks the opposite direction. Since it only allows one direction, it regulates. Okay. What is the name of a given form of interference that seriously degrades, obstructs, and repeatedly interrupts radio communication service? Is it adjacent interference, disruptive interference, harmful interference, or intentional interference? Harmful interference, disruptive interference. I think disruptive interference is my call right there. Because it's not harming, but it's constant. No. They're saying C, it's harmful. Interesting. I have to remember that. Well, either it's disruptive or it would be harmful. Harmful interference was starting to grow on me, but it's the way that they worded it. Kind of sounded like it was degrading over time. So it wasn't trying to be harmful. It sounded like it was already interference that was disruptive. That it was there, but it wasn't there. I didn't think it was harmful. But intentional, not a chance in hell. Adjacent interference, never heard of that. Either it would have been harmful or intent, but it didn't sound like it was being harmful. So, but then again, they looked at it as a harmful interference. So, go with what the book says. What effect does Troutsbury bending have on the 2-meter radio wave? It reverses the sideband of the signal. It garbles the signal. It causes it to travel shorter distances. It lets you contact stations farther away. So isotropic ducting. You might have seen this if you ever had an antenna and try and tune in a station too far away, you're getting its signal. But it won't last for a certain amount of time. I've seen it happen on TV. When I lived in Mississauga, I used to get in CKCO. It's the station out here in Kitchener-Waterloo. Too far away for an antenna to pick up 90% of the time. But there'd be those days where I could pick up the station clear as a bell. So isotropic ducting bending has the same theories on TV. Yeah, go ahead. Not a problem. I understand. To the 5 people that are watching, thank you so much for sticking around. Or the 4 people that are now here. Let's go on to the next question, shall we? In an amateur digital radio system, the modem is connected to the blank. Computer, antenna, amplifier, input, output. It's only one place it's connected to. Computer. Obvious one there. Next. In the event of interference to a neighbor's television receiver, according to the EMCAB-2, it will be determined that the amateur it will be determined by the radio amateur transmission that is the cause of the problem if its field strength A on the neighbor's permission above the blah 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 specific immunity criteria. If the transmission location is above the radio amateur's maximum allowed transmission power, at the transmission location below the amateur radio's maximum allowance of transmission power, or near the TV below the information science camera, specific to the immune criteria. This, if I remember correctly, has something to do, we're interfering with TV. We're interfering with him receiving the frequency. This is one of those questions where I just go, ooh, okay, think. I believe it is D if I remember correctly. Nope, it's A. So it's at the neighbor's premises above the Innovation Canada Department of Canada specifically immunity criteria. Yeah. So it's on the neighbor's premises. So its TV is not receiving properly and is causing the interference. When always in doubt, take the longer answer. A Canadian radio amateur operating his station 7 kilometers or 4 miles offshore from the coast of Florida is subject to a frequency band limit of an ITU Region 2. Those applicable to the U.S. radio amateurs. Those applicable to Canadian amateur radios, or a ITU Region 1. Canadian amateur radio operating a station 7 kilometers, 4 miles offshore off the coast of Florida. Region, I want to say Region 1. I know we're Region 2. Ontario is Region 2, but they're in Region 1. I think it's Region 1, if I remember correctly. Nope. Applicable to the U.S. station. Okay. Little question like that can throw you for a loop and a half. The fee for taking the amateur radio certification exam at blah, 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 blah is $20 per visit, regardless of the number of qualifying examinations. $20 per qualify, no charge, or $5 per qualifying examination. If I remember right, it's $20 per qualification, if I remember correctly. I could have sworn it's 15, but maybe it's 20. 15's US, 20 in Canada. That's right. The drain field of an effective how do you pronounce that? Translator corresponds to the blank of a bipolar transmitter. Okay, so that either is the base, the collector, the emitter, or the source. We're talking about the drain. So the drain has a gate and has a ground. In the middle is for the gate is also could be the collector, if I remember correctly. Yeah. The receivable means to prevent. The reliabilizer means to prevent or indicate overmodulation must be employed at the amateur station if a person other than the holder of an authorized is in use of the station. A telegraph key is used. DC power input of the encoder and collector circuits. Our final RF stage are receiving 250 watts. Or a radio telegraphic is used. Vowel means preventing an incident of overmodulation must be employed at the amateur station is a person other than the holder of the amateur radio station. A radio telegraph is in use. DC input of the analog collector of the circuit is final RF stage is exceeding 250 watt. Well, the wattage is over exceeding. That'll be C. Submit. No. Radio telephone is in use. So are they talking like the microphone is in use? I think they're talking about microphone there. $34. A parasitic oscillation is a product of the transmitter isotropic stage, is unwanted signal developing in the transmitter, does not cause radio interference, is generally parasitic elements of a Yagi antenna. Well, parasitic would mean it's not good. Let's put it this way. It's like a parasite almost. So this would be parasitic. This would be causing unwanted signal. I would say it's B, unwanted signal in the transmitter. The distance to Europe from your location is approximately 5,000 kilometers. What sort of propagation is most likely to be involved? Will be tropospheric scatter, multi-hop, backscatter, or sporadic E? Oh, God, this one. Isotropic scatter would cause your signal to go farther. Multi-hop means that your signal then bounces back and forth on the from Earth to the isotropic Troutsbury, then down, then up and down, up and down, up and down. That's how HF is basically travels. Backscatter? No. Backscatter would just be everywhere. That would be just causing interference. Sporadic E? Oh, man, I'm not 100% sure on this one. I don't think it's multi-hop. Scatter has no control unless you're using a Yagi antenna. I think it's sporadic E, if I remember correctly. No, it's multi-hop. Okay, so it's far enough that it can do a multi-hop. Okay. Okay, AC we know is alternating current. And it looks like waveform. But is it a complete cycle will be one wavelength, if I remember correctly. The operation of an amateur radio station shall ensure that communications are limited to the messages of the technical or personal nature. Changes are properly applied to third-party communication. All communication are conducted in secret code. Communication exchange only with commercial stations. Okay, so we know B, we know C is out of order because you're not allowed to send any messages with a code that's not available to be decoded without a decode being available. So if I said, let's meet at the coffee crunch by saying, oh, let's go meet at at that place last month. Well, right there, I'm kind of like doing that in secret because I'm not telling anyone else where we're going. And in amateur radio communication, if I remember correctly, you cannot use code, so we know that can't be used. Applied to third-party communications, probably not. That involves that could include sensitive information that you wouldn't want to trade on the airways because anybody can listen to it. And see, exchanging with a commercial station, you don't deal with commercial stations. So it goes to A. In Canada, 10 meters amateur band is corresponds to the frequency 2. Okay, 50 to 54 megahertz doesn't sound right, since we already know that 6 meters starts at 30. So would it be 21 to 245? 28 to 29? This sounds like it's 14 is the 20 meter band, so I don't think it's that one. 24 to 27. I believe it's 28 to 2970. Or I could be wrong on that one. Let's see. 14 is 20 meters. 7 is 80. 30 meters is the 6 meter band. That's really close to the 6 meter band. A does sound a little right, but looking at the band, I don't think it's right. 24 has a bigger, like C has a bigger bandwidth. That sounds like that could be for 12 or 11 meter, which is used by CW. But also B could be that too. 50 to 5400 megahertz. No, because that starts at I think it's this band. I could be wrong. Let's see what happens. Nope, it's A. Damn. Is it the plate or is it the cathode? In a vacuum tube, electrodes that are emitted to electrons is the... I think it's cathode, if I remember correctly. Yeah, it's cathode. Okay, next. Regular power supply output of the filter connections connections to the blank transformer, rectifier, output, or regulator. So in a power supply, the output of the filter is connected to the what? Transformer, reflector, output, or regulator. Well, it's already saying the output is connected. So we have the output filter already connected. So we know it's not output, or it could be output. Transformer is what we call the whole power supply, I would think. Reflector, rectifier, I should say, or regulator. Rectifier, I think, sounds right. But I have a feeling this is going to be wrong too. Nope, regulator. Okay, so Q codes. This is the fun part. Q signals indicate that you want the other station to send slower is QRN, QRM, QRS, or QRL. I know QRM, it means interference. I don't believe it's QRN. I believe it's QRS, if I remember correctly. Yeah, QRS, send more slowly. In a single sideband CW receiver, the antenna is connected to the blank. Local isolator? Yeah, sorry. Local oscillator? Immediate frequency amplifier? Radio frequency amplifier? Product detector. Product detector sounds kind of weird. Local oscillator? Maybe. Radio frequency amplifier? Very possible. Or intermediate. I'm going to say radio frequency amplifier. This is something new, Code 6. Part of the Canadian amateur books. This is one of those new questions that kind of threw me for a loop. When I studied the first time to get my license, I've never ran into this question. I've never heard of Safety Code 6, but here it is. Which of these statements about Safety Code 6 is false? Safety Code 6 sets limits and terms of power level leading into antennas. Safety Code 6 sets limits to allow rates of which RF energy is absorbed in the body, specifically the exponent rate. Safety Code 6 limits the contact that could draw from underground poorly grounded objects. Safety Code 6 sets limits to include current electrical fields, strength, magnetic fields from electromagnetic radiation. Safety Code 6 mostly deals with RF and electrical interference. I think A is the wrong one. A is false, yes. Safety Code 6 is really interesting to read. If you can get the amateur radio information, look up Safety Code 6 in amateur radio. There's a whole write-up about it. It's actually fairly interesting to read more about how they regulate it and how they control it. You're now transmitting FM on a 2-meter band. Several stations advise you that your transmission is loud and distorted. A quick check of the frequency counter tells you that your transmission is on the proper field. Which of the following probable cause is causing distortion? The frequency counter gives you the incorrect reading and you are indeed off frequency. The power output voltage is low. The frequency definition of your transmission is set too high. The repeater is reversing your sideband. Now, we're not working sideband, so that has nothing to do with that. Frequency counter is giving you incorrect readings, and you are indeed off frequency. Could be a possibility. Power supply wattage too low? No. I know that you can sound distorted if you're yelling into your microphone like really loud, and what's happening is everything's getting too loud and it's bouncing on frequency. I've heard of that. The frequency definition transmission set too high. Could be. Repeater is reversing everything on sideband. I remember that being an answer for one of the questions. I'm not sure if that's the one. Things transmitter frequency is set too high. Yeah. What are some reasons not to use parallel conductor transmission line? You must use impedance matching devices for your transceiver. It does not work very well in high SWR. It does work well when tied down to metal objects. And you should use a balun, and you may have to use impedance matching devices with your transceiver. It does not work well when tied down to metal objects and cannot operate under high power. It's difficult to make at home and does not work very well in high SWR. Well, anything doesn't work well in high SWR. I believe this one does not work well with metal objects. if I remember correctly. Yep. When in doubt, go for the longest question. An SWR meter measures the degree of match between transmission line and antenna by comparing forward and reflecting voltage, measuring conductive temperature, inserting a dioide in the transmission line, or measuring radiated RF energy. Now, SWR stands for single wave reflection, or SWR. Yeah, I think wave reflection, if I remember correctly, it's a signal wave reflection. That's it. And that is just how much noise is can be carried on the line, if I remember correctly. And I believe it is measuring the radioactive energy, the RF energy, if I can remember correctly. Nope, compensating forward and reflective voltage. That's what it is. Okay. Approximately how much gain does a half-wave dipole have over an hyperspace radiation? Oh, crap. That question. Yeah, this is one of those questions I get really hung up on. Three decibels, 2.1 decibels, or 1.5 decibels, or 6 decibels. I think if I remember, it's 2.1 decibels higher. Or is it 1.5? Something tells me it's 6. Let's go with 6. No, it was B. Dang. I was going to go B. If I was 2.2 to 1, well, it's 2 to 1. Makes sense. But I thought in decibel power, I'm thinking like audio decibels. Ugh. Communication receiver has 4 filters installed on it, respectively designed at 250, 500, and 2.4 kilohertz. Sorry, 250 hertz, 500 hertz, and 2.4 kilohertz, and 6 kilohertz. If you were listening to single sideband, which filter would you utilize? If the signals are all broadcasting, and those are all lower sideband, when I want a 6 kilohertz filter, or would 6 kilohertz block out all of them? I want to say the 250, but then 250 and anything below 250 would be blocked by the filter. So I say 250. 2.4. Interesting. Wonder why. I'll have to look that information up afterwards. And that could be easily answered by me just talking to talking to people I know. So I'm going to have to figure that one out. That's a really good one. I'm going to write that one down so I remember to look at that one. Okay, practice exam. B dash 003 dash 10 Okay, this is an interesting one. If a neighbor reports television interference, whenever transmitting, no matter what band you use, what's probably the cause of the interference? Too little transmitter harmony suppressing, incorrect antenna length, receiver VR tube discharge, or receiver overload. If I remember correctly, it's receiver overload. Yep. Okay, overload receiver. Now the receiver can't receive any signal. Doesn't matter what channel he turns to. Because I've overloaded the receiver and the receiver cannot work properly. Okay, people, we reached the halfway point. Now it's just downhill all the way down from here. But I might call it early. I might. What time is it? We still got time. Inductive resistance may be increased by an increase in the amplified voltage, a decrease in the supplied current, an increase in the applied frequency, or a decrease in the applied frequency. Well, we know I don't believe it's caused by a decrease. So I think we can take applied frequency and applied voltage out. And I don't think an increase in supplied frequency would do it. Sounds like an increase of supplied voltage would make a conductive reactance because reaction. Just by knowledge of how electricity works, I think it's A. And A just sounds like the right one. When actually it's the C, applied frequency. And I said that. I wasn't too sure. So the Canadian exam is a lot harder than the U.S. exam. The U.S. exam is only 26 questions. I do pretty well in that one. I only fail by one question. Okay. Insulators. Insulators are what electricity won't pass through. Okay? Aluminum, it'll pass through. Plastic, rubber, wood, carbon, it'll pass through. Glass, air, plastic, porcelain. Air is not an insulator. Glass, wood, copper, porcelain, metal. Paper, glass, air, aluminum, no. So it'll probably be glass, air, plastic, and porcelain. So insulator is just protecting you from electricity. Electricity travels through metal objects. So anything that contains metal would not work. Carbon is a metal. Steel is a metal. Copper is a metal. Best way to know it, if you need an insulator, how does power not travel through? What can power not travel through? Can't travel through wood. Wood is too porous for it to travel. Porcelain is made out of clay. Clay that's already hardened, that has no water molecules, can't pass through it. Water is conductive under certain circumstances. If it's salt water, is not productive, is not current cannot pass through salt water. Too much of a elements are in it that can cause it not to work. But you take, but air is nothing. There's no conductiveness to air. So that's how it works. Plastic is not conductive, and neither is porcelain or glass. At what point in the solar cycle does 20-meter band usually support worldwide propagation during daylight hours? Only at the maximum point of the solar cycle, at any point in the solar cycle, at the summer solstice, or only at a maximum point in the solar cycle? Well, we know that the solar cycle is every 7 years. And we know 20 meters is where everybody goes to get the best band propagation. That being said, we're at the bottom right now of the propagation cycle. It's starting to climb up. We're starting to see some more travel again. I'm going to say at any point, because it seems like 20 meters tends to work any time of the year. A person found guilty of transmitting false fraudulent defense distress signal or interfering with obstructive of radio communication without a lawful cause may be liable summary to a conviction of a fine not exceeding $5,000 or a criminal or a prison sentence of 1 year or both. A prison term of 2 years, a fine of $10,000, or a fine of $1,000. Well, I can see jail time. I can see a fine. And it's the longest answer in that whole section, which tells me that's the answer. Sometimes you're not sure, go for the longest question. The input of power to the final stage of your transmitter is 200 watts. The output is 125 watt. What's happening to the remaining power? Is it A, it's being used to provide positive feedback? It's been used to provide negative feedback? It's been used to provide greatest efficiency? Or D, it has dissipated in heat loss? Well, we know for energy to go down, it dissipates in heat. So it's D, dissipating in heat. To the three that are still watching, thank you so much for sticking around. Hopefully you're finding this as entertaining as I am, and you're enjoying what you're learning. Because honestly, learning about ham radio and taking the time to do these questions, for me to do this, it's very important because I want looking to get my HF license. If you are already amateur radio, throw your call sign out there on the in the chat if you wish. I like to know who's watching and just see, and just chat with you guys also. So don't be afraid to say hi and say, hey, I know that question. It's a tricky one. Whatever you want to say. You're all welcome in here, people. So don't be afraid to say hi. So come on in, enjoy it, have fun. Anyways, getting back into the questions here. 55. This is question 55 in my practice exam. To reduce harmonic output from a high-frequency transmitter, you would put a blank in the transmission line as close to the transmitter as possible. Would that be a low-pass filter, high-pass filter, band rejector filter, or a wave trap? Well, it's harmonic output from a high-frequency transmitter. We want to reduce it. A band rejection filter blocks all other bands except for the one band. A low-pass filter blocks low-pass signals. A high-pass filter, it takes out high-pass. Because we're doing a harmonic output, a low-pass filter would allow lower signals to pass through. So harmonics would be lower. So a low-pass filter would not work. High-pass filter allows higher signals to go through, not lower signals. That could block. A band rejector filter, I think, bands the band and rejects all transmissions and receiving of that band. Or B, a band rejection filter is just made to receive only that one band, and that's it. I'm leaning towards high pass filter, actually. Low pass. Damn it. Okay, so it's a low pass. Like I said, it's probably going to tell me that I got to restudy my electrical information. So anyways, in an HF station, which component is temporarily connected to a tuning process for adjustment to a transmitter? Well, the only one that makes sense is an antenna tuner, because that's what you use it for, to tune your antenna for transmission. Really, a dummy load. That is interesting. If I was an antenna tuner, honestly, I'm kind of surprised dummy load. Dummy load is used as a way for us when we're adjusting, when we're trying to get our radios just right. But it's mostly used in testing purposes, not used for tuning. Most people use an antenna tuner for tuning. And that's what I thought it was going for. I guess I misunderstood it, and it's dummy load. Next. If an amplifier becomes nonlinear, the output of the signal would cause isolators, overload power supply, be saturated, or become distorted. If I remember correctly, you put too much power into something, it becomes distorted. What's the best way to keep unauthorized people from using your amateur radio station at home? Well, putting in a lock on it would be the best way to do it. But anyways, they say A, using a carrier-operated relay in the main power line. B, use key-operated on-off switch in the main power line. C, put a danger high voltage sign on the station. Or B, put a fuse in the main power line. Well, A, you always want a fuse in your main power line to protect your amplifier from getting overloaded. Using key-operated on-off for main power line? Me, I would just go in the breaker room, pull the breaker, and make sure the breaker's not accessible. But I guess that's also B. Holder of an amateur radio operator certificate with basic qualifications is authorized to operate the following station: a station authorized in the aeronautical service, station authorized in the amateur service, any authorized station except for authorized in the amateur and authorized on marine services, or a station authorized in maritime service. It's actually B, station authorized. We're allowed to operate amateur radio stations because we're amateur radio operators. Pretty basic answer. Which of the following statements is correct? Ooh, I gotta be correct. Any person may operate an amateur radio station under supervision and under the presence of a person holding an appropriate qualification. A radio amateur may permit any person to operate a station without supervision. A person holding only a basic qualification may operate another station on... Yeah. Any person operating a station in the amateur radio service. So which statement is correct? Any person can operate an amateur radio station under supervision and presence of that person holding the appropriate qualifications. So say if a friend wanted to use my radio and wanted to see what amateur radio was all about, I could say here. But my hand would be on the power button to turn it off immediately if he says something stupid. But I could pass him the hand mic, say, okay, you want to transmit, here's my hand mic. My hand's on the power button. You say something stupid, I can easily turn you off, and I don't get in trouble. So, BA. Bingo. Let's see how many people have been on the channel so far. Well, we've had a lot of activity today. I meant since I came on. We had a lot of people calling in, so that's kind of cool. I'm just checking out 3023. Okay, let's go to the next one. Why should you use only good quality coax cable and connectors for UHF antenna system? To keep standing wave ratio of your antenna system high, to keep power going into your antenna system from getting too high, to keep RF loss low, and to keep television interference high. Well, we don't want to keep television interference high because we don't want to interfere with any television, so that would be wrong. To keep standing wave ratio antenna system high, you don't want high standing SWR. That's not healthy. To keep power going to your antenna system from getting too high. To keep RF losses low. Yeah, you want as much energy to go out to that antenna. So it's going to be C. The power of a transmitter is increased from 5 watts to 50 watts by a linear amplifier. The power gain is expressed in dB is it A, 10 decibels, B, 20 decibels, C, 40 decibels, or D, 30 decibels? This question's hard. I don't remember how to calculate this. I'm going to say 5 watts to 50 watts is 20 decibels. It's actually 10. Damn. If you make a halfway vertical antenna for 233 megahertz, how long would it be? 128 centimeters, 50.4 inches. 105 centimeters, 41.3 inches. 87 centimeters, 25.4. Or D, 135.6 centimeters, or 53 NX. Now, I don't know what the 233 megahertz range would be, but I figure it's going to be a long antenna. I think it's 105. I could be really wrong on this one, but I'm thinking that's what it is. Like I said, thinking because I can't remember the math for this one. 67. Damn. Smaller. In a 3-Yagi element directional antenna, the blank is the longest radiation element. So in a Yagi, we have 3 elements. The shortest one is the director. The middle one is the driven element. And the one in the back is the reflector. And usually the reflector is the longest object in a antenna. So when I studied a little bit about radio, I was always told that we should be only in English. But because we're in Canada, we can use English or French as our first language. So it's English or French for us. But I was always taught that English is the main language of amateur radio, and then you can use like whatever language that you're from, but you have to dress yourself using your own language. But apparently, that doesn't matter. Okay, 66. Why should you keep transmission lines short using a repeater? A long transmission may prevent someone with an emergency from using the repeater, to see if the receiving station operating is still awake, to keep long distance charges down, to keep listening non-hams a chance to respond. Well, non-hams can't go on our repeaters. There's no long distance charge. Receiving station still awake. No, it's A. Long transmission may reject emergencies from coming through. Like, hey, everybody, watch out. There's a tornado coming our way. Run. And I'm talking to, say, someone else going, hey, how's the weather today, huh, Frank? Is the weather good? Oh, I'm so bored. I'm just sitting here. And, I see this tornado here, but I don't think it's a problem. I think I'll be okay. Yeah, I can't see that happening. Can you? Next. 67. Which of the following statement is not correct? Okay. A curious operator refrains from using offensive language. A radio amateur may not operate or permit or operate a radio apparatus which he is known is not performing in the radio communication regulations. A amateur radio may use a linear amplifier to amplify output of a licensed exempt transmitter outside of any amateur radio oscillation. Considerate operator does not transmit unnecessary signals. This one just sounds serious enough that it would be B. And instead, they wanted C. May use linear amplifiers to amplify the output of a licensed exempt transmitter. Also here, because a licensed amateur knows that a radio station is not working, we're not supposed to be operating it. Radio amateur may not operate or permitted to operate a radio apparatus which he knows is not performing in the radio communication regulation. That is actually in the book. I'm surprised they wanted C. But C makes sense too, unfortunately. So when is a radio amateur operator allowed to inform information on the general public? Only when the broadcast is longer than 15 minutes, when the broadcaster is less than an hour, only when the operator is being paid, or D, never. Remember correctly, it's D. Never. The purpose of using a 3-wire power cord and plugging amateur radio equipment into it to prevent internal short circuit, to make it convenient to use, to prevent the plug from being reversed in the wall outlet, to prevent the chassis from becoming live, which is D. Because your third pin is your ground, which is that little round pin. The way you look at a power line, it looks like a power plug looks like a face. Well, that little circle at the bottom, that is your ground line. That should be totally discharging. So that's your earth to ground line. How should your position... Okay, let's do this again. How should you position the antenna of a handheld transceiver while you are transmitting? Point it away from the station that you're trying to contact. Point it down to bounce the signal from off the ground. Away from your head and away from others. Or point it towards the station you're trying to contact. Well, gee, I think it's D. You want to point it towards the station you want to contact. No, they want you to point it away from others. But also you want to point it away from others. Yeah, that's obvious. But you also want to point it towards where you're trying to contact, right? Okay, so the isoponics is reflecting high-frequency radio stations. Depends on at the power transmission line, by the receiver's sensibility, by the amount of solar radiation, or by the type of atmosphere and weather conditions. Well, this sounds about right, like upper atmosphere weather conditions, but actually, I believe, if I remember correctly, it's the amount of solar radiation that controls the ions that are in the air, which then controls signal. Which two electrical units multiplied together gives you units of watts? Volts and amplimeters, amplimeters and henries, farads and henries, volts and farads. I know Ohm's law is power over... Okay. These volts and amplimeters, I'm feeling that's wrong. Volts and farads. Farads and henries. Amps and henries. Amperes and henries, I don't think. And farads and henries doesn't sound right either. I think it's volts and amps. Yeah. To lower the resonant frequency of an antenna, the operator should ground one end, lengthen it, center feed it with a TV ribbon transmitter line, or shorten it. You want to shorten it. Because the shorter it gets, the more it falls out of range, wouldn't it be? Oh, no, they want to lengthen. Okay. A solid gold tolerance band on a resistor indicates the tolerance is... So, on a resistor, we have different colors. I don't know what color it is. 5%, okay. That's vertical, if I remember correctly. Or it's horizontal, I can't remember. I believe it's vertical, if I remember correctly. Nope, horizontal. Ah. What would be a large size resistor used instead of a small one of the same resistance? If I remember correctly, it's dissipation. It's more greater power dissipation because resistance means resisting the power. The large size would be used And then the small one would get whatever, give you better power dissipation, I would think. But it could be also less impedance on the circuit. But you're adding impedance to the circuit. So I think it would be power dissipation. Okay. Which of the following is not a scattered mode? Forward scatter, back scatter, side scatter, inverted scatter. I think it's inverted scatter. Yep. Your total station was heard on 21.357. By the same time you were operating on, but at the time you were operating on 7.25, what's the reason that this could have happened? Your transmitter was radiant harmonic signals. Your transmitter power supply capacitor was bad. You were setting CW too fast. Your transmitter power supply filter choke was bad. Well, you're transmitting on a harmonic signal. That's the only thing that makes sense. What does your term antenna front to back ratio mean in reference to a delta loop antenna? Oh, I love these questions. And by the way, we're past the 2 hours, but because I've been doing a lot of explaining, I'll have this done like 20 minutes ago. So anyways, let's look at this and try to get through this. So what does the term antenna front to back ratio mean in reference to a delta loop antenna? Is it A, the number of directors versus the number of reflectors? The power radiation of the major radiating lobe is compared to the power of the radiation exactly opposite to the direction. The power rated is the majority radiation lobe compared to the power radiation 90 degrees away from the director. Or C, the relative position of the driven element is respected to the reflector and the directors. So a loop antenna, which basically makes your left and right curved around and connects. So if I remember correctly, you're actually forcing yourself to make a lobe comparable to power radiation 90 degrees away from that direction. So what we're saying is these are curved down, so your radiation is going to be up here at the lobe. If I remember correctly, I believe that's what it is. Yeah. You want to install a lightning resistor on your antenna transmission line. Where should it be installed? Anywhere on the line, closest to the antenna, outside, closest to earth ground as possible, or behind the transceiver. It's actually outside, close to the earth ground as much as you can, because when lightning goes, it's going to take the fastest way of resistance. And if the ground isolator is pushing the energy right down to the ground, that's where you want it to go. Also, keep in mind, if you run an amateur radio station, you want to take off that antenna during a lightning storm. You don't want a chance that lightning's going to hit your antenna and blow out your equipment. Keep that in mind. Let's go into this. So, an unmodulated carrier may be transmitted only if the output of the final RF amplifier is to keep under 5 watts for brief tests on frequencies below 30 megahertz, when transmitting single sideband, or in frequency below 30 megahertz. I can't remember this. I think it's when transmitting single sideband. Nope. 30 megahertz. Okay. In frequency modulation receiver, the output of blank is connected to the mixer. Oh, nice. Frequency discriminator, speaker or headphones, intermediate frequency amplifier, or local oscillator. I don't think it's a discriminator. Intermediate frequency amplifier. It's receiver, so it's not a transmitter. So speaker or headphones could be connected to the mixer. But the mixer also can connect to the local oscillator, sending out the receiving the signal. But I'm going to say stereo headphones, speakers or headphones, because that one sounds like that would be the most reliable, most obvious. Nope, local oscillator. I was right to begin with. Damn it. Midway, dusk, dawn, or midnight. When is the ionosphere most ionized? Well, that's probably midday, I would think. And midday is correct. Skywave is another name for a spheric wave, tropospheric wave, inverted wave, or ground wave. Well, we know it's not ground wave. We know it's not an inverted wave. It's either tropospheric or ionospheric wave. I'm going to say tropospheric. I have a feeling it's ion. You know what? Let's go with ion. If I feel it's ion, I'm going to go with what I feel. Yeah, ionospheric wave. So this one is really tricky because when you hold even my amateur radio license, I'm allowed to go with crazy wattage. So anyways, which of the following is the most powerful equipment holder of basic with honor certificate can legally operate at full power? 160 watts, 200 watts on HF, 100 watts on HF, or 600 watts PEP HF linear amplifier. If I remember correctly, I believe it's 200 watts on HF we're allowed to use. Nope, it's 160 watts. My mistake. Wah, 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 wah. Yep, it is A, 160. I goofed. So we got 85 right. We got 52 out of 100. Not good numbers. Automated level control, ALC, in an SSB transmitter controls the peak of audio input so that the power amplifier is not overloaded, reduces transmitted audible feedback, reduces system noise, or increases occupational bandwidth. Well, the ALC is supposed to keep your sound level. On single sideband, we don't want it overdriven. So I'm going to say it controls the peaks of input so the power amplifier is not overdriven. In the amateur radio service, it's permissible to broadcast music? No. Radio communication for immediate safety and life of individual immediate property or protection of property. Programming originating from broadcast studio? No. Commercial recorded material? Hell no. B. Because music costs money. We don't pay for licenses for money for radio. So we're not a commercial standard, so we don't have to worry about that. All right. Next one. The amateur radio operator certificate should be retained on the amateur radio person, retained in a safety deposit box, remain address provided, so it remains at the address provided, or retaining the amateur radio's vehicle. Well, see, the funny thing is, in the book, it does state that you have to keep your license on you whenever operating a device. So it'd be on the person, which is right here. This is my radio operator's license. But at the same time, you got to store it at your house. So the one that they are looking for is retained at the address provided. But in reality, we got to carry it on us in person too. So I carry it on person. Stereo amplifiers often have long leads which pick up transmitted signals because they act as receiving antennas, frequency discriminators, transmission antennas, or RF emulators. Well, receiving antennas, because they have power to receive. The receiver picks up the signal. If that wavelength happens to be at the right chord of the stereo speaker, it can pick up the sound. I know, strange, huh? In standard international phonetics, the letter D stands for what? Dog, Denmark, Delta, or David? Well, this should be obvious. Delta. So we use the NATO command. So that's Alpha, Beta, Charlie, Delta, Echo, and so on and so forth. There's actually you can actually look it up online. There's a whole phonetic alphabet that you can find online. They'll tell you what the radio call signs are, like X-ray, whiskey, and so on and so forth. There are some out there that are just like, whoa. Like, for R is Romeo, J is Juliet, M is Mike. Say my call sign. I'll be Victor, Alpha, 3, Foxtrot, Uniform, Charlie. But I've also heard U for uniform being actually Union. So I got to check that out again and make sure I got that right. In a single sideband transmitter, the output of the blank is connected to the balance modulator. I hate these ones. Is it linear amplifier, speech amplifier, various frequency oscillator, or filter? Well, I don't think it's a filter. It's a transmitter. So would it be the speech amplifier goes to the balance modulator? Or would it be the linear amplifier? I want to say speech. My body says linear. Let's see which one it is. Speech amplifier. Okay, so I was right. Which of the following is not considered to be a communication on behalf of a third party, even though the message originated or addressed to non-amateur? All messages received from Canadian stations, a message originating from Canadian Forces affiliate radio service, a message that's handled within the local network, a message addressed to points within Canada. I think it'd be originated from the Canadian Armed Forces, if I remember correctly. Yep. Unless you're Canadian, you would have not known that answer. That's all I can say. What is the best method to tell if a band is open for communication with a particular distance location? A, telephone an experienced local amateur. B, listen for signals from that area from an amateur beacon station for a foreign broadcast or television nearby frequency. Ask others in your local 2-meter FM repeater. Look at the propagation forecast in the amateur radio magazine. Well, listen for signals in your area from an amateur radio beacon station or a foreign broadcast television station on a nearby frequency. Usually we use beacons to figure out if bands are open. If you can hear a beacon, that means that band's usually open. So I'm going to say B. We listen for beacons. How is a voltmeter connected to a circuit that's under test? Well, it's usually used in phase with the circuit, in series with the circuit, in parallel with the circuit, or in quantics of the circuit. Well, I've never heard of quantics in the circuit. I'm going to say in phase of a circuit. No, it's in parallel with the circuit. My mistake. Either it would be parallel or it would be serial. Usually I heard it was in phase, but I guess it's not in phase. So I was wrong. The usual effect of the isotropic storm is to prevent communication by ground wave, to increase maximum usability, to cause fade out in skyway signal, produce extreme weather changes. Well, we know the isoperic storm can really prevent a lot of communication. You can't use high ground. You gotta use ground waves in most cases. I'm going to say it causes fade out of skyway signals. Because if there's storms in the isoponics, it can actually knock out those spheres, so you can't even get your signal through, which allows it to pass through the ionosphere. Annoying as it is, but those things do happen. If two equal values capacitors are connected in parallel, what is their total capacitance? The same value across either capacitor, half the value of one capacitor, twice the value of the other capacitor, or the value of one capacitor times the value of the other. Well, we know it's not in series, so we know that power is being divided by a parallel. And they're connected in parallel. So I think it's twice the value of one capacitor or the same value of either capacitor. But I think it doubles, if I remember correctly. Yeah, twice the value of one capacitor. What kind of payment is allowed by a third-party message to be sent by amateur? A donation of amateur equipment. No payment of any kind is allowed. Any amount agreed upon in advance or donation of equipment repairs. Really? We're not allowed to accept any money whatsoever. It's sad, but it's true. I mean, if someone wanted to donate me equipment, I would say, sure, you want to donate it to me. But there really is no payment required. So we're not allowed to accept anything. But I have a feeling we're okay. If someone would donate equipment after the thing was done, because they want to show you some love, like thank you so much for what you've done. I don't know. I'd have to look into that a little bit deeper to see if that's still allowed. Okay. The department that is responsible for administration of the Radio Communication Act is, well, we already know this answer, B, Innovation Science Technology of Canada. Used to be known as Industry Canada, but they don't do that anymore. So got changed over to this company. Okay, guys, we're almost at the last two questions. So here we go. Last two. What is a low angle radiation pattern that's ideal half-wave dipole for free space installed in parallel to the Earth? Interesting. Okay, long range antenna, low angle radiation pattern of ideal half wavelength dipole. RF and free space installed parallel. It means up and down to the earth. We're going to have two lobes on either side, I would think. A is two small lobes on one side of the antenna and one on the large on the other side. Is it a figure 8 perpendicular antenna? A circle, equal radiation in all directions. It's a figure 8 on both ends of the antenna. I don't believe it's a figure 8. That means the figure 8's at the very top of the antenna, and it's doing a figure 8. Oh, figure 8 at both ends of the antenna. Or is it a circle? Which means it's all around the antenna. I believe it's radiation all around the antenna, if I remember correctly. I don't believe it's two figure 8s. But I could be wrong on this one. But I think, if I remember correctly, it's a circle. No, it's a figure 8. Damn. Oh well. Okay, a permanent magnet would be mostly likely made from aluminum, copper, brass, or steel. If I remember correctly, it's steel. Let's see what we got. Finished exam. I failed it, but we're okay on operations. We're pretty good on regulations and policy. Where are we weakened? 38. Feed line. My basic theory is pretty bad. And same with my circuit component. So 4, 5, and 6 I'm really bad at. Okay, I'm going to take a picture of, I'm going to make a copy of this. So I have it stored. So that's the Canadian exam in a nutshell. Very, 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 very technical. Now, like I said, this episode is just being put up for fun. If you found this informative, hey, comment down below in the comments. Let me know. I'm not going to tell you to subscribe. I'm not going to tell you to like it. That's up to you. If you found this informative, then fine, like it. If you didn't find this informative, thumb it down. But I'd like to know what your thoughts are. Would you like to see me do more of these exams and continue getting up there? Now I failed. I only got 64. But let's put it this way. When I wrote my exam, I was sitting at 67%. My last two tests were at 67. When I wrote my exam, I got 74. So, yeah, it's one of the things. But I want you to look at this exam. But this is just gives you an idea what we go through in Canada to get your amateur radio license. It's really technical. But I hope you guys found this entertaining. And hopefully we'll be able to get some more content out. I have something coming out soon about this radio right here, the ICOM 51A. I'm not doing a review on it. So I'm just going to do an overview of it. I'm not going to do any operations with this radio yet. The reason I have this radio is to talk a little bit about D-Star, show you guys D-Star, how it works on this radio. But the reason for that is because there's a new D-Star radio coming out, the 52A. I'm going to write the ICOM. I'm going to see if they offer people to have a look at the ICOM 52A and see if I can get one lent to me, not own, lent for evaluation purposes only. And it'll be sent back to ICOM or whoever lends it to me. I do not want to own that radio. I will buy it with my own money. Let's just put it that way. Once I have the money, I'll buy it. But if a company is willing to lend me one for review purposes only, then I will review it. And I'm going to be writing out to I'm going to be writing a letter to one of the companies out here that I know that might be able to help me out. If they say no, I'm also writing a letter to ICOM to see if I can get one lent to us so I can review it at least. I'm not looking for, I'm willing to send it back to them, whatever needs to be done. I just want to be able to borrow it, look at it and go, yeah, that's a good radio. And say, yes, yes, it's worth buying. But yeah, I'm going to look at these questions. I'm going to definitely make a copy of this and get it out to my my person who's helping me study for the test and see what he says and go from there. Anyways, guys, thank you so much for watching. I appreciate all you viewing in, and I'll catch you on the next one. So thank you so much, everybody. Bye now. Forgot I had to end stream. Stupid me.